Let's start with practice paper 5. Question number 1 says 2-point charges 5 into 10 to the power minus 19 and 20 into 10 to the power minus 19 are separated by a distance of 2 meters. The point on the line joining them at which the electric field intensity will be 0. So you have to find that point where the electric field intensity, net electric field intensity due to both the charges becomes 0. So let's draw a rough diagram. Here it is 5 into 10 to the power minus 19 coulomb. And let's say here it is 20 into 10 to the power minus 19 coulomb, right? And the separation between them, okay, that is how much given? 2 meters, right? So they are separated by a distance of 2 meters. Now let's say at any point P, the electric field is 0. Be very careful, this point P is not the midpoint. This can be any random point between the line joining the two charges. And at this point, if you want to find the electric field, where will be the direction of electric field due to the charge at A? It will be radially outward because it is a positive charge. So positive charge, the field lines are radially outward. So let me write here EA. And electric field due to the negative, due to this one, charge at B will be radially outward on this side. So this will be electric field EB. So electric field due to A and electric field due to B. Okay, we got. And both have an angle of 180 degrees. So net electric field at any point P will be how much? It will be EA minus EB, or you can keep it EB minus EA. Okay, depending on the magnitude. So the resultant of both the electric field will be EA minus EP. But the question is saying the electric field intensity at that point, at point P, is 0. So let's put here 0 equals EA minus EB. Let me take this EB on the left hand side. So electric field EB equals to EA, and that's obvious. If two vectors are in opposite direction and the resultant is 0, they should be equal and opposite, right? Yeah. So EB, electric field, okay, due to B will be at that point. Let's say this point is X from the first charge. How much distance it will be away from the second charge? 2 minus X, because the separation is 2 meters, right? This whole distance is 2 meters. So from first charge, if it is X, other charge it will be 2 minus X. So here electric field due to B will be K charge on B upon separation, which is 2 minus X whole square. That is equals to K charge on A upon separation, which is X square, correct? Now let's cancel this K on both the sides. And what is our charge on B? 20 into 10 to the power minus 19 whole divided by 2 minus X whole square. And this is equals to, what is the charge on A? Charge on A is 5 into 10 to the power minus 19 whole divided by X square. Great. Now let's cancel out here both. And if you cross multiply, you will get 20 upon 5 equals 2 minus X whole square upon X square, correct? And 20 upon 5 is nothing but 4. Okay, that is equals to 2 minus X whole square upon X square. Now what we will do? Now we will take the root. So on taking the root, it will give you 2 is equals to 2 minus X upon X. You can take minus 2 also. You will get a negative result. But here we should have a positive result because it is in between the line joining the two charges. So 2X is equals to 2 minus X when you cross multiply, and take this minus X on the other side. It will be 3X is equals to 2. So X is equals to 2 by 3. At a distance of 2 by 3 from the first charge, the electric field intensity due to both the charges is 0. So here the correct answer is 2 by 3, option B. Let's move to question number 2. Great. Question number 2 says 2-point charges. First one is 0.2 coulomb, okay, and 0.4 coulomb are placed 0.1 meter apart. The field at the midpoint will be, so here this time you have to calculate the field. It is not given that the field is 0. Be very careful between the previous question and this question. So here I am taking a 0.2 coulomb and here I am taking 0.4 coulomb. Let's call it as charge A, let's call it as charge B. The separation between them is how much? 0.1 meter. So this AB gap is 0.1 meter. Now they are saying the field at the midpoint. What will be the midpoint? P. So what is the gap between P and A? 0.1 divided by 2. So I'm just roughly writing here 0.1 divided by 2. This is the gap. between AP and same gap between PB because it's a midpoint, right? Now let's find the directions first. Electric field due to the positive charge radially outward. Electric field due to the positive charge radially outward. This is EB and this is EA. Both are aligned at what angle? 180 degree. So the resultant at EP will be EB minus EA. Sir, why you did EB minus EA and not EA minus EB? Because EB, the charge at B is greater. So stronger will be the field. So to keep the magnitude, okay, positive, we did this EB minus EA. Great. Let's move ahead. So what is EB? EB is equals to K charge on B upon separation. Separation is what? R by 2 whole square. Or let me not make it R by 2 to confuse you. I'll just simply take what is the value here, 0.1 upon 2 whole square. Okay. Minus, I'll put the values, other values also. K QA upon separation is what? Again 0.1 upon 2 whole square, right? Now you can see here K is constant and K is common also. So let's take this K common out. 9 into 10 to the power 9 common out. And even this 0.1 whole divided by 2 whole square, that is common. So what you left with here? Charge on B minus charge on A. What's the charge on B? 0.4 coulomb minus charge on A, 0.2 coulomb. If you have any confusion how I took this common out, you can simply multiply this back to the bracket. So if you multiply this whole parameter back to this first term, you will get the first term, right? And the second term, you will get the second term. Great. So here we can write it now in a much better way as 9 into 10 to the power 9 and 0.1 whole square. Okay, let's make it as 0.01 and 2 square, which is 4, will go on the top, into 0.4 minus 0.2, 0.2, correct? And when you remove this decimal point, you will get into 100. So this will become 9 into 10 to the power 9 into 4 into 20, right? 0.2 into 100 is 20. Now 9 4s are 36, 36 into 10 raised to 9 into 20. So this we can make it as 36 2s are 72 or into 10 and give one 10 to this, 72 into 10 raised to 10. That is how much? Newton per coulomb. Let's see if there is any option. So 72 into 10 raised to 10. Now you can see here 72 is not there, all of them, only this is there with 10 to the power 13. But we can see here this is 7.2 into 10 raised to 11, which is same as 72 into 10 raised to 10, correct? So let's move to question number 3 in practice paper 5. So question 3 says 2 point charges 10 microcoulomb and 40 microcoulomb. So let's say this is our 10 microcoulomb and this is our 40 microcoulomb placed at a separation of 20 meter apart. So let's say this is 20 meter apart. The point on the line joining them at which the field is 0. Now be careful. Now the field is given. They are not asking, like unlike the second one. This is similar to question number 1. So field is 0. We have to take any point P and this time it is X distance. When you are looking for that, you have to take it X. And what is the distance here? 20 minus X from the second charge, right? Okay. And you can see both are positive. So again, the field will be radially outward for the first charge. Let's call it as A. Let's call it as B. And here, this is EB. So you can take EB minus EA or EA minus EB. Here it doesn't matter because the resultant is 0. So EP is equals to EA minus EB. And what is EP? 0 equals EA minus EB. Taking EB on the other side, it will be EB equals EA. And what is EB? K charge on B upon separation. What is separation? PB square equals K charge on A upon separation PA square. Let's substitute the values. Before that, cancel K with K. What is Q? B, 40 microcoulomb. Micro means 10 to the power minus 6. And what's PB? 20 minus X whole square. Charge on A, that is 10 microcoulombs, so 10 into 10 to the power minus 6. And what is PA? PA is X square. Let's cancel out here 10 to the power minus 6 with minus 6 and cross multiply. You left with 40 upon 10 is equals to 20 minus X whole square by X square. Now 40 over 10, that is nothing but 4, and that is 20 minus X upon X whole square. Taking the root both the sides, This will give you 2 and 20 minus x upon x. Cross multiplying, 2x is equals to 20 minus x and 3x is equals to 20. So x is equals to 20 upon 3. Let's see if there is any option with x is equals to 20 upon 3. Yes, option C is there. Question number 3, practice paper 5. Let's move to question number 4. Question number 4 says 2-point charge is minus 10 nanocoulombs. So this is our minus 10 nanocoulombs and minus 90. So let's place here minus 90 nanocoulombs. Both are placed 80 meters apart. So let's keep here, this is 80, this gap 80 meters. The point on the line joining the two charges where the field is 0. So similar approach, let's do here. Let's take this as point P, let's call it as A, let's call it as B. But be very careful the directions, because this time this is negative charges, right? So for negative charges, electric field will be radially inward. So this side will be not EB, this will be EA. And this time this side will be EB. Though they look similar to the previous case. Both are opposite in direction. So again, electric field at point P will be EA minus EB or EB minus EA. So resultant is 0. Let's call this point as X. This will be 80 minus X, right? So 0 equals EA minus EB. And if I take EB on the other side, it will become EB equals EA. Now what is our EB and EA? EB is K QB upon what's the separation? 80 minus X whole square. And EA, K QA upon X square. Now K cancels with K. What is the charge on B? Minus, but you will not take the sign because you have already considered arrows. Once you have considered arrows, okay, that is included. Because that is negative sign, that's why the arrow is in that way, right? So 90 into 10 to the power minus 9, because it's nanocoulomb. So let me make it minus 9 whole divided by 80 minus x whole square. And what's the charge on A? 10 into 10 to the power minus 9 whole divided by x square. Let's cancel out the things which are getting cancelled. 10 to the power minus 9 with 10 to the power minus 9. And cross multiply, you left with 90 upon 10 is equals to 80 minus x whole square upon x square. Great. Now what you have to do next? Next we have to cancel 90 upon 10, 9. And we can write it here as 80 minus x upon x whole square, right? Taking the root, it will give us 3, which is 80 minus x upon x. And cross multiply, this will give you 3x is equals to 80 minus x. So 4x is equals to 80, or this implies x is equals to 80 upon 4, which is how much? 20 meters. So let's see if there is any option with 20 meters. Yes, option B. Correct answer is option B for question number 4. Our question number 5 says 2-point charges are placed as shown in the figure. The net electric field due to both the charges at any point P will be. So you are given with first charge over here 20 nanocoulombs, another charge is over here 32 nanocoulombs, both are separated by 2 meters. We have to find the net field at any point P over here. To find the electric field at point P, what we can do? First, due to the first positive charge, because both are positive charges, so first positive charge here in this direction, electric field due to charge at A. And electric field due to the charge at B will also be in the same direction. So let me put it with a different color, EB. Why both in the same direction? Because both are positive charge and field due to positive charges is radially outward, right? Okay, great. So since both are in the same direction, the net electric field at point P will be EA plus EB, correct? Now what will be EA, EB? Let's find them separately. EA here will be K QA upon separation is AP square. Be very careful with separation in these type of problems. What will be electric field at P due to B? So EB will be K Q at B upon, what's the separation now? BP square. I hope this is clear. So let's put it there, and net electric field at point P will be EA, which is K taking common charge QA upon AP square plus QB upon BP square. Now what is QA? The charge at A, 20 nanocoulombs, QB 32 nanocoulombs. What is AP and BP? Let's write it separately here. AP is nothing but 2 meters and BP is nothing but this 2 and this 2, which is 4 meters. So this is 4 meters. I hope this is clear. Let's substitute here the values and get our final result. So K is nothing but 9 into 10 to the power 9. Charge at A is 20 nanocoulombs, 20 into 10 to the power minus 9 upon separation AP is 2 meters, so 2 square is 4, plus charge on B, which is 32 nanocoulombs, 10 to the power minus 9 upon separation 4 square is 16 meters. Let's simplify it further. So this will be 9 into 10 to the power 9, and I am taking 10 to the power minus 9 common because it's there for both the terms. So 20 upon 4 plus 32 upon 16, correct? So this will give us 9 into 20 upon 4, 5, and 32 upon 16, 2. So this will be 7 into 9, 9 into 7, and 9 sevens are 63. 63 newtons per coulomb. That's our unit. So correct answer is 63 newtons per coulomb. That's option C. Let's move to question number 6. 2 point charges plus Q and 4Q. Both are separated by a distance of 6A. So let me take here, first one is Q and second one is 4Q, and both of them are separated by what distance? 6A. The point on the line joining of the two charges where the field will be 0. So quite similar to previous questions. Okay, let's call it as A, let's call it as B. Let's say this point is point P, which is at a distance of x from the first charge. So from the second charge, it will be 6A minus x, right? Because the total length is 6A. So if it is x, that will be 6A minus x. Electric field due to the first charge, since it's positive, radially outward. Second charge, again positive, radially outward. So this is our EA and this is our EB. Now electric field at point P will be EA minus EB. And as per the question, it is 0. So 0 equals to EA minus EB, and taking EB on the other side, it will be EB equals to EA. EB is nothing but KQ by EB, separation PB square, plus is equals to EA, KQ charge, this is QB, QA upon separation AP square. Let's cancel K on both the sides and see what we left with. So charge on B is 4Q, PB is 6A minus x whole square. And charge on A, Q, and AP is nothing but x square. Now let's cancel out the terms, charge Q with Q, and 4 will be equals to 6A minus x whole square upon x square. So when you take the root here, taking the root now on the left hand side, this will give us how much? 2 equals 6A minus x upon x. When you cross multiply, 2x is equals to 6A minus x, and 3x is equals to 6A, and this implies how much? X is equals to 6A upon 3, which is 2A. The correct answer is 2A. Let's see if there is any option. Yes, option B for question number 6. It was question number 6, paper 5. Let's move to next question. 2 point charges are placed as shown in the figure. The net electric field due to both the charges at any point P, so this must be the point P, will be. So let's see. First of all, both are negative charges. So electric field due to the, let's call it as A and let's call it as B. Electric field due to the first negative charge, radially inwards towards the charge. This is electric field due to A. Electric field due to B, again radially inwards towards the charge E. So as you can see, both the charges having field which are pointing in the same direction. So electric field at any point P will be EA plus EB. And what is our EA? KQA upon separation. What is the separation? AP square. And electric field due to B will be K charge on B upon what's the separation? BP square. Let me write here AP and BP. So AP is nothing but 4 plus 2, 8 meters, and BP is nothing but 2 meters. Let's substitute here and find the electric field. So EA, let me substitute here and take common K. It will be QA upon AP square plus QB upon BP square. Let's substitute the values now. So what is our first K? K is 9 into 10 to the power 9. Charge on A is minus 36. Will you take the negative sign? No. We have already considered the negative sign in the arrows over here. If it was positive, the arrow would be different. So negative don't consider again. 36 into 10 raised to minus 9. What's the AP? AP is 8 meters, so 64. Plus QB. What's our QB? QB here is charge on B, which is 12 nanocoulombs. And what's the separation? BP? 2 meters. So 2 square is 4. Clear? Now next is, let's take 10 to the power minus 9 common out. So it will be 9 into 10 to the power 9 into 10 to the power minus 9 common out. You left with 36 upon 64 plus this will be how much? 12 by 4, 3. Okay. Yes. AP is 4 plus 2, 6 and not 8. I did a mistake over here. It's 6 meters. 4 meters and 2 meters is 6 meters. So this will be not 64. This will be 36. And here this will be 36. Okay. So we left with, in case if you are confused, let me rewrite it as 12 by 4. So this will give us 9 into 36 upon 36, 1 plus 12 by 4, 3. So this will be 9 into 4, 36. That's the answer. Newton per coulomb. Let's see if there is any option. 36 newtons per coulomb. Correct. Option A. Let's move to question number 8 in the same practice paper. 2 point charges are placed as shown in the figure. Okay. You have to find the net electric field due to both the charges at the midpoint. So first of all, if this is 4 meter, let's say this is point P, which is at a distance of 2 meter from here. And this is at a distance of 2 meter from here. Correct? Now electric field due to this negative charge will be radially outward or inward? It will be inward in this direction. So this is our electric field due to A. And where will be the direction due to electric field due to B? This will be the direction EB. The net at point P will be EA minus EB. Now which charge has higher magnitude? 36. So we will say that net electric field at point P will be electric field due to A minus electric field due to B. Why minus? Because both the arrows are pointing in the opposite direction. Now what is EA? K QA upon separation AP square minus K QB upon BP square. Now AP and BP are equal. Be very careful because this is the midpoint. Now if you take common, it will be K will come out and even AP square will come out. You left with QA minus QB. Why? Because AP and BP are equal, so you can take one of them outside. What is our K? K here is 9 into 10 to the power 9. What is AP? 2 meters, so square is 4. Charge on A, 36 nanocoulombs. Be very careful, you will not take the negative sign. Again I am repeating. Minus 12 into 10 to the power minus 9. This negative sign is because of the vectors and not because of the negative sign on the second charge. Let's take 10 to the power minus 9 common and cancel out with this 10 to the power plus 9. You left with 9 by 4 and here you left with 36 minus 12. 36 minus 12, that is 9 by 4 and into 6 minus 2, 4 and 3 minus 1, 2, 24. Let's cancel this 4 and 24. We left with 9 into 6. Okay, and that is 54 Newton per coulomb. Let's see what's the answer. Yes, option B is correct, 54 Newton per coulomb. Let's move to question number 9. 2 point charges, this and this, are separated by a distance of this. So let's draw a rough diagram. 6 microcoulombs, 24 The point on the line joining them at which the field intensity is 0. Quite similar to all previous questions. A, B, and let's say this is any point P. So electric field due to A. Okay, you can stop this video right now and you can attempt this question yourself. Again, then you can resume from here in case if you get stuck somewhere. So this is the best way to learn. So here electric field due to A, since it's a positive charge, will be radially outward. That will be EA. And electric field due to B, radially outward. Okay, EB. Now they are saying we have to find the field intensity being 0. We have to find the point. So this distance will be x, let's say. That will be 6 minus x. BP. AP is x and that is BP is, okay, that. So you can see the angle between both is again 180. So electric field at point P will be EP minus EA. And EP will be 0. So this will be EB minus EA. Let's take EA on the other side. So EA equals EB. And what is our EA? K QA upon what's the separation? Separation is between EA. EA is x square. And there it will be K into QB upon separation is 6 minus x whole square. Correct? Now let's cancel K with K and put the values of the charges. What's the value of charge here? So value of charge QA is 6 into 10 to the power minus 6 upon x square. And here it is 24 into 10 to the power minus 6. 10 to the power minus 6 because it's a microcoulomb. 6 minus x whole square. Let's cancel both and cross multiply. So this will be 6 minus x whole square upon x square equals to 24 upon 6. 24 upon 6 is 4. 6 minus x whole square upon x square. Now taking the root on both the sides, this will give us 6 minus x upon x is equals to 2. And when you cross multiply, this will give you here as 6 minus x is equals to 2x. And 6 is equals to 3x. So x is equals to 2 meters. That's your answer for this question. So correct answer is 2 meters, option C. Let's move to question number 10. 2 point charges, 2 microcoulomb and 50 microcoulomb. So let's see 22 and 50. Both are separated by a distance of 24 meters. Okay, great. The point on them where the field is 0. Quite similar to the previous one. Try it yourself. Okay. And if you are still confused, let's see one more question of this type. So this is A, B. Electric field we have to find. Let's say this point P, the field is 0 and that point is at a distance of x. So this will be 24 minus x, right? Electric field due to the 2 microcoulomb will be radially outward, right? So this will be outward because it's a positive charge. And electric field due to this 50 is this side because it is negative charge, right? Positive charge. So both are radially outward. So electric field at any point P will be EA minus EB. And since it is 0, we can take it as EA minus EB equal to 0. And take EB or on the other side, it will become EB equals to EA. And what will be EB? K charge on B upon separation, PB square. And EA, K charge on A upon PA square or AP square. Let's substitute the values. So what is our K cancels with here K? What's the charge on B? 50 microcoulombs. PB is 24 minus x. PA is x. And charge on A, 22 microcoulombs, 10 to the power minus 6. Let's cancel 10 to the power minus 6 both the sides. 50 upon 2. Cross multiplying. And here it is whole square. 24 minus x whole square upon x square. Now 50 upon 2 is 25. That is equals to 24 minus x upon x. Let's make a big bracket whole square. Taking the root both the sides, this will give us 5 equals 24 minus x upon x. 5x is equals to 24 minus x, correct? 6x is equals to 24 and x is equals to 4 meters. That's our correct answer. Let's see if there is any option with 4 meters. Yes, option B. So this was paper 5.